going to discuss question 14 because it's quite difficult because it involves limiting return. So 18 burns in the air according to the equation below. So you've already got your balance equation. A mixture of C2H6 and O2 at 30 mm mercury and 1 to 4 mm mercury was added into a 7.5 liter flask at a temperature of 27 degrees Celsius. The combustion reaction was carried out until completion. Please highlight this word, carried out until completion. Well, this means that one of your return must be your limiting return. Okay, so you have to figure out your limiting return first. So what the question asks is to calculate the total pressure of the gas mixture obtained at the end of the reaction at the same temperature. Okay, so just calculate the total pressure. Give your answer in millimeter mercury. So the question specifically asks for the pressure to be in millimeter mercury. Okay, first thing first, we need to find our limiting return. Okay, so write down your storyline first. Okay, again, we've got C2H6 with pressure of 30 mm mercury and O2 with a pressure of 1 to 4 mm mercury. So this container, when they are mixed in a container, it has a volume of 7.5 liter and temperature of 27 degrees Celsius. Again, calculate the total pressure of the gas. Okay, this is not a displacement of water question, so we can be considering of using the formula of PV equal to nRT. Okay, or we can use the formula of partial pressure. Okay, so but P pressure of C2H6 is equal to the mole of C2H6 over mole of C2H6 plus mole of O2 times total pressure. So let's check which one would be easier for us to use to find the final answer. Okay, so if we want to find the total pressure, then volume already must be total. So your mole must be total and your temperature must be total as well. Well, again, I said that the question will only give you one temperature, so just use that one. Okay, but if you want to use this formula to find your pressure total, then it would involve a lot of work. Okay, you've got this already, but you've got to find the mole for both return, which we're gonna be difficult for us because we don't have the mass. So cancel off this formula. We're not gonna use this. Okay, we're gonna use this one, the ideal gas equation. So first find, okay, check. Sorry. So first thing first, check what we have at the ideal gas equation in order for us to find the total pressure. Okay, so first rearrange your ideal gas equation. So we want to find PT, so mole temperature times RT divided by volume total. Second, check your info. Well, what do we have in this question? Okay, we want to find this. Do we have mole total? No. Do we have R? Yes. The temperature? Yes. Volume? Yes. So the only thing that we need to find is the mole total. It's gonna be easy for us by using again the ideal gas equation. But class, you must alter this ideal gas equation. Okay. So next is we want to find the mole total using ideal gas equation. So just change your lower subscript. Okay, so we want to find the total mole. So we know that the mole total is equal to mole C2H6 plus mole of O2. Okay. So your PV equal to nRT. Okay, let's say we want to find the mole of C2H6. Okay, volume must be total. Temperature, okay, you can write it down as total as well because we've got only one temperature in one question. But pressure and mole must be respective to the one that you want to find out. So rearrange first. So mole C2H6 is equal to P pressure C2H6 times volume total divided by RT. So pressure C2H6, do we have it? Yes. But remember class, if your pressure must be in ATM, right? But the question gave you the pressure in millimeter mercury. So you need to convert both of the pressure given into ATM. So that would be 0.03947 ATM, and the pressure of O2 would be 0.1631 ATM. So 0.03947 times 7.5 divided by 0.08206 times temperature, convert it to Kelvin. So you've got 300 Kelvin. So your mole will be 0.012024 mole. For the mole of oxygen, that would be 0.1631 times 7.5 divided by 0.08206 times 300. That will be 0.04964 mole. Okay, remember that we need to find the mole, which one is the limiter return. Okay, so now draw your beaker or your ratio. Well, depending on what method that you want to use to find the limiter return. Well, I'm used to using my beaker because I found it to be easy to have my information in one place. So my mole provided, and this is my beaker of mole needed. 0.012024 mole. This is the mole for C2H6, while the mole for oxygen is 0.04964 mole. Okay, so 27. So mole needed. Okay, I've already made a cross multiplication, so I've got my mole needed of C2H6 as 0.014183 mole, and my mole needed for oxygen would be 0.042084 mole. So my limiting return would be C2H6. Alright class, I forgot one thing. Okay, we are discussing about limiting reaction question, right? So your mole total, okay, at the end of your product, okay, so you've got the, sorry, this is not your mole total. Okay, your mole total would be, sorry, my mistake, would be the mole of product, which is your product would be CO2 and water. And okay, remember that we have excess reaction, which is not completed at the end of reaction. So you need to find the mole of excess. Oh, sorry, mole of unrated excess reaction. Okay, so this is our mole total. Okay, this question is a bit hard, I know. I hope you won't appear on your PSPM this year. So we don't have all moles, but we can find the mole of product, which is CO2 and H2O, by using ratio with limiting return. And for the mass of unrated excess mole, you just need to minus the mole provided minus the mole needed, okay, of your excess reactant. So we found out that the limit reactant is C2H6. Okay, so put a star on it. Okay, so now we're gonna compare all of your products with C2H6 in order to find respective moles. Okay, so first I want to find mole of CO2. So from equation 4, mole of CO2 is equivalent to 2 mole C2H6. Okay, remember class, we need to take the mole provided by the limit reactant because this is how much I can give you. Okay, that's the maximum amount of mole that I can give to you. So 0.012024 mole. Oops, sorry, I got it wrong. This is the one that we want to look for. Okay, so from equation, your 2 mole of C2H6 will be 0.012024 mole. So your mole CO2 would be 0.024048 mole. Next is to find the mole of water. So from equation, 6 mole of water is equivalent to 2 mole of C2H6. So 0.012024 mole C2H6 is equivalent to 0.036072 mole of H2O. Okay. The last thing is to find the mole of unreacted excess reactant, which is 0.04964 minus 0.042084, which is equals to 7.556 times 10 to the power of minus 3 mole. So you've got all the moles needed to find your mole total, right? So calculate your mole total. So this is your mole of carbon dioxide plus the mole of water plus the mole of unreacted excess reactant, which gonna be 0.067676 mole. Okay, we are done to find our total moles. So lastly, we can figure out our total pressure. Okay, which we already written at the top in here. Where is it? Yep, in here. So we've got the mole total already. So yes, now we can calculate our total pressure, which is the mole total times the RT divided by volume total. So 0.067676 times, okay, the temperature would be 300 divided by the volume of 7.5. So you've got 0.22214 ATM. Okay, class, please look back at the question. Okay, they want the answer in millimeter mercury. Okay, since we are using under gas equation, our pressure would be in ATM. So just times it with 760 millimeter mercury. Okay, so you've got your final answer as 168.83 millimeter mercury. So see how we're gonna how they combine question for chapter 1 and chapter 5.